So we're here on a beautiful evening, actually in front of the Niels Bohr Institute, where the group who have been attending the conference is, well, let's look at it. It's unique. Are we a unique species on a unique planet? We still don't have that answer, but I'm here with renowned scientist, astrobiologist, someone who's on roller skates in back of us, renowned astrobiologist Pascale Ehrenfreund of George Washington University in Washington, D.C., who I wanted to comment. I want to get your opinion on the most recent tantalizing sample from Perseverance that is going to be probably one of the first samples that we try to retrieve from Mars. What are your thoughts initially from what you read about this potential sample?
Well, I mean, the whole Perseverance mission is really very exciting, and there have been very interesting samples, but this one is really a sample of mudstone, and this is a material where you can preserve organics over a long time, and they have found many different clues, which will, I hope, be explained in very big detail in a publication. But it seems to be one of the most interesting samples they have collected so far. It's, I think, the 22nd, a core sample, and the
22nd core sample that Perseverance has collected. And
yeah?
what caught their attention, do you think, about this particular sample?
Well, it has leopard spots, and they are created by probably reactions of microbial communities, and they are different than other rocks. They also find other minerals and olivine and phosphates, and the complete picture says that this could be very interesting and could have supported microbial communities in the past, and it seems to be different than others.
A microbiological community?
Yeah.
Okay.
Microbes have somehow are imprinted, in the rock in a way that they have just changed the rock, and I think this is something which might be very interesting. Of course, it would be great if we would have the samples in a laboratory, but I'm sure they will analyze more and report more. And I have just asked some experts, and they also think that it's really I'm not a geologist, but I work a lot on life detection on Mars, and also some experts think that it could be really interesting to have those samples also brought back.
So this looks like potentially it could be a signature of some sort of microfossil of microbial life, is what you're saying?
Yes, certainly, of course, extinct life, extinct life. Extinct life, of course, yeah. But it could have been that micro communities have, changed the rock and make these special shapes and these leopard spots, and in the context.
And you're saying what? Leopard spots?
Yeah, that's how they call it. They call it leopard spots.
Like an animal, the leopard.
Exactly. That's what they call it, yeah.
Okay, but that's not a technical term.
No.
So how do we avoid, because you remember the Alan Hills controversy, from the mid-90s, the meteorite that was thought to have spherules that were indicative of microfossils, and then that was disputed and pretty much has been disproved. How do we know that we're not getting excited about a sample that will turn out to be something of geological and exploration?
Obviously, I mean, this is always the case, and they're quite honest, in their interpretation that it looks very interesting. There could really be microbial life be involved, but they also say that there could be really thermal processes which could eventually give the same signature. So they are quite honest about it, and they also argue, if we would have the samples back, back and could analyze them with high resolution instrumentation in a laboratory, we would know much more. And that's why those samples are collected.
And so last question,
Yeah.
and that is, when do you think that we will, have you heard from your colleagues at NASA or your contacts at NASA about funding for any sort of sample return, actually? Because that's been the problem.
Well, first I want to say that mass sample return is a mission which is planned since 5 decades, and actually there's an interest in communities all over the world, and it has been, you know, a leading mission in the decadal planning of the US National Academy. So it is a very important mission for the community. It is very expensive and it is very complicated, and it also requires international cooperation. And we all hope that, you know, the current, you know, budget cuts and so will be resolved in some time, and that we are able to make this mission happen, for which we are waiting since decades.
But these samples will be preserved and waiting for us, even if it takes 5 or 10 years to get there.
Definitely, they are in a very radiation protected environment, and they can wait. But the mission is complicated, and it needs international cooperation. So it needs progress in order to really happen. And a lot of people have started working on it and make plans, you know, for orbiters and landers. And we hope, you know, that this mission will continue and will bring the samples back.
Okay, well, thank you so much, Pascale, for taking the time to talk to us.
Thank you.